My name is Tyler Erickson. I've been a developer advocate on the Earth Engine project now for over 10 years. And I love Python. So I don't necessarily love the Python logo because I'm not sure it looks totally like Python's. But over the years, I've spent a lot of time with Python in trying to manipulate geospatial data, both before coming to Google and then for the last 10 years as part of the Earth Engine project. Earth Engine itself on the back end doesn't understand anything about Python or JavaScript, but we have these client libraries that sit in front of it that most people interact with Earth Engine through these client libraries. You can go directly to the REST API and make calls there, but most of the time you're developing an algorithm that's manipulating data, taking different data sets, applying operators to them. And that's much easier to do in the client library when you're doing algorithm development. So that's why most people will work there. Once you have developed a script for Earth Engine, either using JavaScript or the Python client library, you can access it in a variety of ways. It can be from like a command line tool, could be from a web application like this. There's a lot of Python and JavaScript web frameworks that can actually talk to our client libraries. But they're not great for actually developing the algorithm in the first place, which might be where at least somebody that's coming to AGU will probably spend more of their time developing the algorithm than building an application on top of it. So for JavaScript developers, we have a development environment that we have built and support ourselves. It used to be called a playground. We usually refer to it now as the code editor. And this is a self-contained interface that has a map output on the bottom. It has documentation. It has asset management. A lot of the stuff that you would need to kind of organize your geospatial information and write an algorithm using the JavaScript language. But what do you do if you love Python instead? The best solution I find is actually using Jupyter Notebooks, some version of those development environments. And there's a variety of different versions that we'll go over here quickly. But that is the way that I find that most people that want to develop a new algorithm on Earth Engine that uses Earth Engine and for a Python user will use Jupyter Notebooks. If you're not familiar with Jupyter, it is a set of open standards for interactive computing, and they are implemented in a variety of different software packages and projects. At Google itself, we have something called Jupyter Lab, which is a full-blown kind of, well, actually, let me back out to outside of Google, there is a standard Jupyter Notebook server. It's kind of the reference implementation that the Jupyter project has for displaying a single notebook. They also have a more recent kind of version called Jupyter Lab, which you can do multiple notebooks at the same time and integrate it in a lot of other visualizations that are not necessarily in a notebook. So it's actually a more powerful IDE for working with Python algorithms. And then within Google, we have Collaboratory, which is a hosted service that will allow you to work with a single notebook at a time. And then there's also within Google Cloud, there's Vertex AI Workbench, which is Jupyter Lab, but connected to a lot of the other Google Cloud services. And then this is just a short list. I mean, it's used throughout Google in a variety of other different ways of research and other groups, et cetera. Kaggle, the data science competition, has these concept of kernels, and they also use the Jupyter protocol in order to implement these, the work that they do for the data science competitions. So it is a really powerful and important set of open standards that a variety of different companies, Google, Microsoft, Amazon, and others basically use to make a single kind of notebook description that can work and be displayed in a variety of environments. There are differences between them, but there is also a lot of standardization between the notebooks as well. So this is just a picture of like the basic Jupyter notebook. The real powerful thing about this for like AGU folks that are doing research is that you can describe your research in a lot of detail. It's not just code with comments. The comments can be very rich. They can basically have markup, they can have links, mathematics, images, videos, all kinds of stuff can be right there with your live code. So it's a very powerful way for explaining an algorithm. There's a variety of kind of pros and cons in Earth Engine of like working with the JavaScript code editor or Python in the Jupyter environments. And I'm not going to go too much into detail in here. The summary is that we have found with the JavaScript code editor, it's easiest to get started because we're handling almost everything for you, the setup of your environment. So it's how we do our tutorials, most of them, and it's how we do a lot of our code examples and documentation. But once you understand that, you can do a lot more, I feel, with Python, because there's a lot of flexibility to connect Earth Engine to all of the rest of the Python ecosystem, which has a rich set of visualization tools. It's just, I guess, a lot more flexible, but it does require some setup assembly in order to make it useful. So Colab itself has done a little bit of that setup for you. Some of the benefits are that it's already integrated with GitHub or Google Drive for sharing your code, your notebooks that you have created. Earth Engine is automatically installed as a library in there, so there's no reason that you have to pip install. It's just there by default. And if you're pulling data and actually doing machine learning, like on deep neural nets, it has access to free GPUs. And this is good if you're experimenting with something that's on the order of working out with it for an hour or something. But if you go away, Colab will recycle the VMs. So if you're using something for long-running processes, like for a day, or you want to keep it open for a week, one of the other Jupyter environments that you can install and have it keep being persistent is probably a better choice than Colab. But we use a lot for demonstration, and it's what I'm going to be demonstrating today. I'm going to just show you kind of it's not a beginner notebook by any means. It's what we used for teaching one of the 4-hour AGU sessions on Saturday to explain a pretty complex data set called Dynamic World, which there are quite a few talks that are going on with Dynamic World in AGU and in the booth this week. But I'm just going to use this as an example of what it looks like to work with Earth Engine and Colab, or from within Colab or a Jupyter environment. So the first thing that's going on there is that there was a little bit in the upper right work that was going on to connect this notebook to a programming kernel. And this is something that the Colab team manages. It fires up automatically. And this is also the part I warned you, if you move away for too long, it's going to recycle the VM and you'll have to start over. So it's not persistent. You have to keep working with it. But once you have that notebook connected to a programming kernel, you can then go through your cells. And a lot of these right here are just like descriptive cells. But the first one that does is a coding cell in gray here that actually does something real, is going to be something that does authentication. And the way that we authenticate is by using Google Cloud projects. So I have to basically go in here and change it to the name of a cloud project that has been authorized to use Earth Engine and that I have access to. So this, for this machine here, is called Earth Wall Master. If you sign up for Earth Engine and use the JavaScript code editor with a Gmail account or most other accounts, you can basically just create a cloud project from within there. So it's not like a big step in order to do that. But you do have to establish one because this is the way that you authenticate to Earth Engine. So I'm going to run this. It says it was not authored by Google. That is actually not true. I am at Google and I'm the one that wrote this notebook. But in general, it's saying you really need to trust what you're running there. Make sure that you know who gave you this notebook because it is pretty powerful. It's having access to Google Drive, Google Cloud, if you give it access to it. So make sure that you trust the code that you're running in a notebook. This is just a good overall idea. So this did an authentication here, and I can tell it's successful at the end because we have a little printout that says it was successfully initialized without any errors. There are multiple ways to authenticate, and those are described in our documentation. So there are different ways depending on what your setup is, how you're running Colab, or sorry, Jupyter in Colab or otherwise that you might want to look into. But for the purposes of this, we are authenticated now. You can notice as I'm going down here, there's a table of contents on the left-hand side that highlights like where I am, and that's organized into sections according to the markdown that I put into the text cells here. So right now I'm under the setup header and installing and importing Python packages, and then I have a little section that talks about a particular package called Earth Engine Jupyter. But just to point out that Colab and other Jupyter environments tend to have this organization where you can actually make a table of contents as you're writing your code. So I have been writing over the past few months a library to build some of the core functionality that you want to see in Jupyter if you're interacting with Earth Engine. And it's called Earth Engine Jupyter. So it just went through and make sure that this was installed into the Colab kernel and then imported into this notebook. And this is an active thing that I'll talk about a little bit later, but it provides some functionality that we'll see here that allows you to display different Earth Engine results. There's a lot of imports here of different Python packages. This is where the flexibility of notebooks come into play. Lots of different packages that are useful for gathering information, visualizing information, etc. That's here. And then there is a particular cell in here that is important for Colab because of the security model that Colab has is more restrictive than other Jupyter servers like the Jupyter Lab or the classic notebook server. We need to actually explicitly say that Colab should trust the what's known as a widget, an output cell. So I basically have one cell in there that's saying, yes, I do want to trust and I want to enable these custom widgets. Otherwise, the security model will actually block some of the stuff from operating in the notebook. All right, so that was a lot of our setup. Let's actually get down into like working with the Earth Engine data. I do have some descriptions in this notebook about the Dynamic World websites. You can do things like make links to external applications or even embed sometimes web pages that describe what your, the data set or the algorithm within your notebook. So that can be very useful. And if I scroll down farther, we can even put other web applications inside of the notebook that were created elsewhere. It's not always the best environment within a notebook to try to manipulate a web application like this, but it is possible if you have a simple one. And then finally, we'll get into some cells here that allow you to start visualizing the data set itself within the notebook. So that was a little bit of like used as an introduction to Dynamic World, but then the core of it is down here. A lot of these sections are kind of compressed right now, which you can expand them out if you actually want to see the details. But you can basically design notebooks so they give a high-level description of what you're trying to describe. And as people dive into the tree, they can expand out and get more details as they need them. For the purposes of this, I'm just going to basically say I want to expand everything in the notebook. And so it's going to make it long, but we'll be able to see all the code in the nodes. You then can start doing some client-side naming, basically a variable. So I have a bunch of different parameters that are going to describe to like the time that I'm interested in displaying, the geography, etc. And if I run these, I ran this before coming in here, so I'm going to actually just scroll down and like look at the results here, so it'll be a little bit faster. Is that we now have an interactive notebook that has a base map, which I think is kind of a beautiful watercolor from Stamen Designs that I'm using as the background tiles, but then it's overlaying data from Earth Engine. It's drawing tiles, and the tiles get loaded as I zoom around. And sometimes it's fast enough that you don't actually even see the tiles loading because that interaction to Earth Engine is rather quick. So that is kind of one of the basic tools that we've added for notebooks that makes it quite easy to work with Earth Engine images there. If I go down a little bit farther, I'm just going to jump to different sections in here that show even more dramatic kind of visualizations of those data sets. This is what's known as there were some manipulations that went in here in order to take a categorical data set or a land cover data set you normally think of as categorical, but actually try to embed the uncertainty in there. So if you see where it looks like it's a depression in there, that means that we're not quite sure about the classification in this visualization. But if it appears to be like high value, a homogeneous high area, that means it's pretty sure that it is a value that we are sure about. One of the other nice things about this type of interface is that we can scroll down here and actually run this. Actually, I'm going to back up a little bit so I can actually get the live stuff running here, because this was saved from the last time I ran it. So I'm going to go here and do runtime run after. So this is going to start executing all the cells after the cell that I was at right there. And we'll start executing them and re-enabling the output. And so that means that when I go down to later on and view the visualizations here, I'll be able to interact with the live data as well. It wasn't cached from before. It has some functionality that you might be familiar with from other kind of visualization libraries, interactive map visualizations. You can turn on and off layers. There's all kinds of different functionality that the leaflet widget library provides that you have access to. This just adds a little bit of functionality to be able to add Earth Engine layers on top of that leaflet mapping library. I'm going to jump down to a few other examples here of what you can do within a notebook. And one of the nice things here is looking at class probabilities over time. So more of a data set. If you're going to try to pull out samples from imagery, you can get it into like a pandas data frame and use pandas, if you're familiar with that in Python, for data manipulation. And then there are, as I said before, access to a lot of different libraries in the pandas ecosystem. One of my favorites is called Altair for exploratory data analysis. That works very nicely in the notebooks as well. So within these notebooks, you can get an interactive map. As you roll over different points here, you can get it to kind of give you back information. There's a lot of rich customization of visualizations that Altair provides for this type of data. And I find that the programming interface to it is really compact and makes a lot of sense after you've done it for a while. You basically are taking a data frame and you're attaching it to the x-axis, to the y-axis, to the color, to the style. It's known as a grammar of graphics approach to visualization, exploratory visualization of data. So that's an example of one of the things we could do there. If I jump down a little bit farther too, I like notebooks because you not only can display images and things like that, but you actually can make it programmatically create these diagrams within your notebooks so that you can get to match up really well with your code. And what I use that for here in this section was to create this, so if I get rid of it here, it's basically being created by this PyDot. There we go. This PyDot library, and it can make a flowchart. And this is describing exactly what's happening in Earth Engine. We have a variable called predictors, an Earth Engine object that we are going to combine with sample points where we have done the sampling for the classification. And using an Earth Engine method called sample regions, we will produce a new variable called training. So instead of having to understand, what is going on with the code, if I go back to where the actual, I have to jump to where it is. There's a run, it's right underneath here. There's a run classification function that I've coded up in Python that has all of these different variables with random training partition, testing partition. It can be hard for people sometimes to follow the logic if you're just looking at code, but with this type of interface, you can actually show them the data flow of how are you taking the predictors, what are you using for training data, how do you actually flow that through to train a classifier, do an accuracy estimate, etc. So I find that to be fairly powerful within here. Let me check my time, how much I got to show you. All right, so I got a few more minutes here. I think at this point, that is going to be my example of a notebook. I have links to it within the presentation, so if you do want to see, explore the notebook itself later, you'll be able to do that. So we'll jump back in the presentation. And I really want to conclude with a lot of where to go next with this. This is just a sampling, and there's so much flexibility and power of using Python and Earth Engine together that here are some of the main places that you can go to if you want to learn more. We do have detailed description of how to install Python in our developer docs. It also goes through the authentication troubleshooting, which is very important depending on how you're trying to install it, because there are different ways to authenticate. And it depends on how your account is set up, whether it's controlled by your organization or it's a Gmail account. There's all kinds of different flavors. So definitely go there first if you have any problems authenticating with Python. We do have an ever-expanding list of Python tutorials, both written by folks on my team that work on Earth Engine and also our experts that are using Earth Engine in the Earth Engine developer community. They can submit and we will publish their tutorials on our website. And there are some incredible ones there on time series analysis, analyzing radar imagery from Earth Engine, a lot of mathematics, a lot of deep technical description in some of those tutorials. At Geo for Good about 2 months ago, we did a intro to Earth Engine and Python session, which was a 2-part, 2-hour session, so 4 hours in total. If you want to watch me and go in excruciating detail of like what you can do in Colab with Earth Engine, it's a long version of what I just tried to give you like a 10-minute overview of. So that's one thing you can do if you want to watch a previously recorded event. The notebooks and the slides are there as well for additional resources. The Dynamic World notebook that I just showed you there, we taught during an earlier AGU session on Saturday. The presentation that describes more about Dynamic World is available at that link, as well as, I don't believe there's a recording of the tutorial that was made, but the notebooks are in there and a presentation that describes the data set. And then finally, I've been spending a lot of my time focusing on making the developer experience for Earth Engine better. And I guess that did not work when I hit on that link. There it is. Actually, it took a little time there. So there is a GitHub project that is called Earth Engine Jupyter there that is pretty early. I only have like 54 commits in there, but I would encourage you to try this out if you are a Python programmer using Earth Engine, and also go and contribute to the issues tab of like what you would want to see there. My hope is that this will form like a lot of the core functionality that other users that are building Python libraries in the Earth Engine community can build on top of, and they don't have to maintain kind of the core functionality. Qiusheng Wu, who's over here, has made an incredible library called GEE Map, and his tutorials on using that are incredible. And so that is like one of the ones I just want to make their job easier, because they've provided such an incredible resource for the community. And there are other developers that are doing the same thing as well. So I'd encourage you to, like, whatever you want to see and you want me to consider to putting into the core Earth Engine Jupyter library, let me know in this issues tab. With that, I think I will go back, I will conclude, and I will go back to that slide in case you want to have links to this as well. So we'll go back to that. Okay. At this point, we have a little bit of time for questions. Maybe just like 3 to 5 minutes before we set up for the next speaker. So is there anybody with a question about this? The question is, what I was showing there in Colab, is it unique to the Colab environment, or I guess to Python environment? The answer is no, generally. Most of the functionality when you're hitting Earth Engine is beyond the client libraries. So JavaScript and Python have access to the exact same objects and the exact same methods. I qualify that saying there's a few little special helper functions that we provide for Python users, and we also provide a few helper functions for the JavaScript users. So it's not perfect parity, but what is happening back on the Earth Engine servers is exactly the same, because the client libraries have to speak the same language in order to get the server to do something. So, yeah. The question was, when you are running in Colab, is it on the Google servers or on your local machine? In this case, Colab is running in a Google data center. It is providing both the web site that you're seeing that's displaying the notebook and the programming kernel behind the scenes. That is different than if you install Jupyter or Jupyter Lab locally. You can have all that running on your local machine, or you can even do some combination of that. You can have the web interface running locally, but reaching out to a remote kernel that might be on some other server at Google or some other data center. So there is a lot of flexibility. What I was showing there with Colab, it is all in the Google data centers there. So that can be great for scalability. We can support so many different users all at the same time because we're relying on Google's scale. But it is somewhere else. You have to be aware that your data is there. And as I said before, it does get recycled. If you stop using it for enough time, it will recycle your virtual machine and you have to start over. Yeah, you can replay the same stuff as well, and if you catch it close enough. But yeah, Colab is on the Google servers.